How does an electricity meter work? And is it true that if I put a bottle of water on top of it, I'll pay less? Hello, Engenharia Detalhada. Today, we're going to unravel a mystery that affects everyone's wallet. How does the electric meter in your house work? That discrete device, often installed on the wall, which decides how much you'll pay the utility company at the end of the month. And more importantly, let's clear up an urban legend. Does putting a plastic bottle filled with water on top of it make you pay less for electricity? But before anything else, we need to understand exactly what we're measuring. A lot of people confuse power with energy, but it's essential to know the difference. Power is the strength with which a device operates. Measured in watts or kilowatts, for example, a shower can have a power of 5,000 watts or 5 kilowatts. Energy, on the other hand, is how much of that power is used over time and is measured in kilowatt hours. Well, it's the kilowatt hour that appears on your electricity bill. And that's what the meter calculates. But how does it manage to add up all that power over hours and days? For many years, the most common type of meter was the electromechanical one, also known as the induction meter or Ferrari's meter. You've probably seen one of these with a metal disc slowly spinning inside it. But what's the magic behind that disc? Basically, the meter has current coils and voltage coils. When electricity passes through your house, these coils generate magnetic fields that interact with the aluminum disc, and this interaction makes the disc spin. The more electricity you consume, that is, the higher the power, the faster the disc spins, and the longer the devices stay on, the more turns the disc makes. A system of gears connected to this disc counts the number of turns, and that's what translates into kilowatt hours. Nowadays, most new installations and replacements use electronic meters, also called static or digital meters. They don't have rotating discs, but they do the same job even more accurately with additional features. But how do they measure energy without any moving parts? The secret lies in the electronics. Inside these meters, microprocessors take thousands of samples per second of the voltage and electric current passing through your home. They then multiply these values to get the instantaneous power, and through complex digital calculations, sum this power over time, calculating the total in kilowatt hours. This is displayed directly on the digital panel. And in addition to being more accurate, electronic meters can record events such as consumption spikes, fraud attempts, and even allow remote reading by the utility company. The accuracy of these meters, whether electromechanical or electronic, is not left to chance. They are designed, manufactured, and tested according to strict national and international standards. In Brazil, the National Institute of Metrology, Quality and Technology, INMETRO, and the National Electric Energy Agency, ANEEL, set standards and regulations to ensure that the meters are reliable. They have accuracy classes that define the maximum allowed margin of error, which is usually between 1% and 2%. This means that if you consume 100 kilowatt hours, the meter may register between 98% and 102%, for example, but this variation is minimal. Meters are subjected to tests for temperature, humidity, vibration, and electromagnetic interference to ensure they maintain accuracy under various conditions. It's important to emphasize that for residential consumers, what really matters on the bill is the active energy. That's the one that actually does the work and turns on the lights, heats your water, and powers your refrigerator. There are other types of energy in the grid, such as reactive energy, which is important for keeping the electrical system running, but it doesn't do any useful work for you. For large industries, this reactive energy can be charged, but for households, the billing is almost exclusively based on your active energy consumption in kilowatt hours. It's impressive the level of control and precision that exists to ensure fairness in your electricity bill. Isn't it this same approach? The pursuit of accuracy flawless design, and the guarantee that everything works as it should. That's what drives engineering in all areas. But now, the million-dollar question and the legend of the plastic bottle filled with water. Does putting a bottle of water on top of the meter really make you pay less for electricity? The clear and direct answer is no, that's a complete myth. There is no physical or technical basis for a bottle of water to alter the measurement of your electricity consumption. But why did this idea spread so much? The belief may have originated from the idea that water, being cold, would cool down the meter and it would register less. However, meters are designed to operate in a wide range of ambient temperatures and are thermally compensated to maintain accuracy. Small temperature variations caused by a bottle of water do not affect the operating principle of the device and do not change the way it measures current and voltage. Water is not a magnetic material that interferes with the electromagnetic fields of disk meters, nor does it change the calibration of the sensors in an electronic meter. So the current that comes through your house and the voltage supplied by the grid don't change. Why would the reading change? It's likely that this myth is also confused with old attempts to tamper with electromechanical meters, which involved using strong magnets to interfere with the disk brake. But even these attempts, besides being illegal and dangerous, are easily detected by modern meters, which have anti-fraud systems. The utility company can identify alterations, broken seals, or consumption below the expected standard, and this can result in heavy fines, retroactive charges, and even criminal proceedings. Is it really worth taking this risk for a trick that doesn't work? Let's do a simple calculation to make the concept clear. Imagine you have a 1000 watt or 1 kilowatt iron. If you iron clothes for 1 hour, you will have consumed 1 kilowatt hour. If the rate in your area is, for example, 80 cents per kilowatt hour, that hour of ironing costs you 80 cents. This calculation is straightforward and there are no variables like water bottles or room temperature that change it. It only depends on the power of your device and the amount of time it stays on. Of course, like any equipment, a meter can malfunction, and if you really suspect that your meter is giving incorrect readings, the right way is not to try homemade solutions or myths. The procedure is to contact your power company and request a technical inspection. They have equipment and trained personnel to check the meter. If it is proven that there is a calibration error or a defect causing the meter to register values outside the tolerance margin, the bill will be adjusted. Your meter is a tool, a precise tool developed based on solid electrical engineering principles and verified by competent authorities. It faithfully measures the active energy you consume, and the idea that a PET bottle with water changes this measurement is a myth without any scientific basis. If you've made it this far and enjoyed the video, take the opportunity to subscribe if you haven't already, leave a like, and activate the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or check the link in the video description. To have access to various opportunities to develop several skills that will make a difference in your career. So, have you ever seen a meter with a water bottle on top? Did you know how these meters worked? Leave your answer in the comments because I want to know. Here are 2 interesting video options that you need to watch to expand your knowledge and explore your curiosity. If you'd like to support us, please like, subscribe, turn on notifications, and consider joining as a channel member. That's it, engineering lovers. Take care, and I'll see you in the next video.